Hello guys, I'm streaming after 2 days because I've been very lazy regarding this and non-serious. Not really, because there are some things going on in my college. Like uh, my end semester exam is closing, and today was type of quiz. So yeah, I'm not able to take out time for this stuff. So now. Uh, we have solved like two out of uh, 75 questions, and now we are on third one. Third, okay. Let me see if my voice is coming or not, and if there is any background noise. I'll begin shortly. Hello, 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 hello. Hello. Okay, it's fine. It's working fine. So let's begin with this. The question says, kids with the greatest number of candies. Okay, there are n kids with candies. You are given an integer array. Oh no, my mother phone. Wait. Okay, I'm back with them with some snacks. Uh, okay, so there are n kids with a given integer array. You are given an integer array candies where each candies I represent the number of candies in ith the ith kid has. Okay, and an integer extra candies denoting the number of extra candies you have. Okay. Oh, okay. So we have an integer extra candies and we have n kids at our door with each of them having candies I amount of candies, and we want to return a Boolean array true for which the ith index of the array is true if and only if we when we give all the extra candies to that ith kid, he has the largest number of candies. Uh, yeah. So, hmm. So what we will do is first make a integer max, which will store the maximum of the whole array, and then we'll add extra candies to the candies I, and at each step we will see if it is greater than the max, and just append that into the array. So the solution will be O of n. So well, this one was quite easy. It actually deserves easy, but there might be some edge cases. We'll have to see about that. I forgot to do bit/std C++. Oh, di parenthesis and p. Oh, it is gone. Okay, max candies equals to int min int. What was the int min, right? Right? It is int min. Hmm. So for each candy, we do max candies equals to max of max candies and candies of I. We can, instead of int min, we can also do candies of 1. But for this, we will have to then make sure that candies is not empty. Well, is there a condition here? N. N 2 to 10 or 2 to 100. So we can do this. Okay. Now we have the maximum number of candies. Then we again do go into the loop and we can uh, like make a like for each loop. Extra candies is greater than max candies. My God, the readability. Then, oh, answer. Answer dot pushback. What we have to push? True. Else answer dot pushback false. Return answer. This should work. What? False? Why? 5. 3 plus 2, 5. 5 false. Yeah, it is not greater. They have the greatest number of candies among all the kids. Bro, they are violating themselves. Greatest doesn't mean greater than or equal to. So this should be false. He doesn't have the first person doesn't have candies greater than all of them. It is greater than equal to all of them. There is a difference. 5 candies, which is greatest among the kids. No. Well, in the sense, like kids have 1, 3. All of the kids combined have 1 candies, 3 candies, and 5 candies. So if you have 5 candies, then you have greatest among them. Ah, okay. That's what they were saying. Like in a set of number of candies, if you have like 5, okay, 5 is the greatest. And if you have 5 candies, then it ultimately means then you have the greatest amount of candies among the kids. So it should be greater than equal to. And I'm not stupid enough to copy and paste again. Okay, let's submit. Yes, first try. First try. Yeah, I'm maintaining a Git repository also. And this is the fugitive uh, plugin for Neovim. And 4, 3, 1. Hmm. Git push origin. Is there a command? Oh, I have to do this. Git. Hmm. Okay, whatever. Oh, okay. Um. It is gonna show my paraphrase. Okay. I'll switch to screen. Another screen. Okay, I'm done. So it has it has been pushed. Yeah. Oh, oh shit. I have to quit. Mm, so the new problem. Can place flowers. Okay, I'm done. You have a long flower bed in which some of the plots are some of the plots are planted and some are not. What is this? Oh, okay. So this is the plot, right? This plot is planted and this plot is empty. The flowers cannot be planted in adjacent plots. Okay. Given an integer array flower bed containing zeros and one where zero means empty and one means not empty and an integer n equals to 1. Return true if n new flowers can be planted in the new flower without violating no adjacent flower rule and false otherwise. Okay, so it is a linear flower bed, right? I am assuming n equals to 1 since n can be. Okay. Hmm. Okay, so we'll make two pointers again. Now my brain is just uh, yeah. How do I explain this? Okay, I'll explain this to you. Just a moment. I can't add. Oh, my OBS is in safe mode. Shit. Okay. So what I can do is enlarge my yeah yeah. So it is like I'll make two pointers. Uh, like first is at the 0th index, and the second is one step ahead of it. And this will see since it is the array of zeros and ones, and alternating should be what should I say? The alternating should be one. It doesn't matter if alternating is zero. Alternating should be one. If adjacent uh, become one, then it is a problem. It's a problem. So we'll make pointer like this. Uh, and no, we can do it with a single pointer also. Single pointer, and we will see like let's say if this is I, then I plus 1 is the adjacent one, and I plus 2 is the one next to it. So we will see like if I plus 2 is 0, then we can add like a flower bed in that. And if like I plus 2 is 1, then we cannot, and then we move. So it's like that. Uh, and we also need to move our pointer first, like I plus plus, until we meet uh, like 1. Then only we try to do it. Or wait, like if it is all zeros and then it is 1 0 1 0 like this, then like we start putting 1 in the beginning. It's in it in the beginning itself. So like I'll try to do that. Yeah, I got the intuition. Hmm. Oh, or what we can do is sum the array. Yeah, 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 yeah. Oh, okay, okay. Like the length of the array is 1, 2, 3, 4, 5, 5, and the maximum number of flower beds that it can hold is 5 divided by integer of 5 divided by 2, right? Plus 1. No, 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 no. It's not actually quite right. Because it can either hold 2 or it can either hold 3. It cannot hold 4. Similarly, for like I equals to 7, it can either hold like 7 by 2. It can either hold 3 or it can either hold 4. That's it. And oh, I got this. And it can hold uh like the larger amount. Like if there are five here, right? Then it can hold 3 flower beds if the first index is 1, right? 1 0 1 comes here, here comes 1, and 0 and 1. So like 3 ones. And if 1 is here and 0 starting index is 0, then 1 0 1 0, and it is the maximum. You cannot add any flower beds than that. So yeah, that is it. And we will see like the number of flower beds it can hold, and the sum, which means the flower beds that are already in it, and we minus them, we subtract them, and then what we have is it greater than or equal to n. If it is, we return true, else false. Okay, 605. can place flower. What is this? What did I press though? F1? Oh, okay. And people ask me, like, why am I making my life harder? Why don't I just use the inbuilt terminal? Bro, who will use this shitty terminal? Even if I do this, like, they'll tell me, oh no, there is a Vim mode in it. Okay, there is. Then what about it? Vim motions, okay. Then and what? Vim motions, okay. But I want this theme. I want my background, and I want this CLang format. Can this give it? Can the inbuilt terminal give this to me? No, it cannot. So this is why I use. Oh no, I to show you this. I like abandoned my file 602. Yeah, this is why I use my editor to do all that stuff. Waste flowers. Oh no. Oh, oh. Okay. So we will make an int total flowers, which is equal to 0 by default, and for int I equals to 0 I less than n. No, flower bed dot size I plus plus. Oh no, not the Microsoft code formatting. That sucks. I used to do that. Now I hate it. Okay. Total was okay. If why am I even doing this? If I can do for each int for auto flower in flower bed total flowers plus equals to flower. Here, right? Either it is 0, either it is 1. If we add 0, it doesn't change. If we add 1, it gets incremented. So, yeah. Now we got the total flowers, and what we're gonna do is, oh, okay. Since the starting position, if it is 0, then the total number of flowers that can be placed in the whole flower bed is flower bed dot size, uh, like integer of flower bed dot size by 2, right? And if the starting position is 1, then it is plus 1 to that. So what we can do is flowers that can be placed is flower bed flower bed's 0th element plus uh, int of flower bed dot size divided by 2. Since if it is the first element is 0, it's not going to change anything. And if the first element is 1, then it's going to increment it by 1. That's what we wanted. So yeah, int max flowers equals to Into max flowers, we're not gonna assign anything to that. But wait, no, okay. Int max flowers equals to flower bed 0. Let's see what is flower bed length. Ah, it is 1. Okay, so we can take this. Okay, right. Flower bed plus integer of flower flower bed dot size divided by 2. So if okay, return if the max flowers minus total flowers is greater than n, greater than or equal to n. Yeah, no, this can be first try. Bro, please. Oh, hell, I jinxed it. Damn it. N is equals to 2. We have returned true, but it is false. Let's see why. You have to place 2 flowers. So we'll put one here and we will put one here, right? Oh, no, we cannot. So what it is essentially doing is, oh, we didn't consider the case where the flower bed dot length is even. Ah, hell no, man. Why? Why didn't I think of it? And the example that I took was also 7. Bro, what the fuck? I should have taken 6 or 8 or something. Okay. Now then, if it is even, then it is 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, then we need not to add this if it is even. Then what we can do is this plus its modulus by 2, right? Oh no. Wait. I'm jumping guns right here. We cannot add its modulus if it is odd. If it is odd and it starts with 0, then it's gonna break. Like, then the logic is not true. So what we can do is, hmm, if max flower bed dot size is equals to uh, %2 push to 0, then we do this. And if it is starting with 1 here, 1, 0, 1, 0, 1, then it is also 3, right? Right? Then it's also 3. 1, 0, 1, 0, 1. Okay, yeah. So it is always flower bed dot size by 2. Else, uh, Oh wait, yeah. If it's not equal to 2, then what we have to do is max flowers plus equals to flower bed 0th element, right? Oh, should have added that as a test case. No, I forgot. Of course. Hmm. 0. Oh, oh no. Oh no. I didn't think about that. Hmm. So we need to take care of the ending also. Max of flower bed 0 and flower bed -1 works in this or not? Does -1 work in this? We have used it as a test case. Ah, -1 doesn't work. Oh, oh no, wait. Yeah. Hmm. Flower bed dot size -1. Oh, it works. Okay. Yeah. Now we submit it. Oh no, bro. Fuck this. We need to calculate max flowers. We can't just do that in O1. What do you expect? No, we cannot. No. No, bro. How should we? Okay, and think I need to pull out this pen tab. Right. Not something sus. Well, I'm not getting uh, encoding overload error today. Nice. But my laptop is heating up like crazy. Where encode. Speaking of the devil, encoding overloaded. What? Why can't I? It is 602, right? Oh no. 605. Okay. So suppose we have like a 1, 0. There should be 1, but it is 0. There should be 0, but it is 1. This is what I'm talking about. The most unusual case possible. Okay, this is the one. Ideally, what should have been here is 1, 0, 1, 0, 1, 0, 1, 0, 1. So these bits are incorrect. So the maximum that we can pull here is we cannot put anything here, not here, not here. Oh, we can. I made a case where I can't even put n equals to 1. Wait, this is not what I wanted. Yeah, I need to add some zeros. Okay, and a few of him here. Okay, so what where we can put one here, then we cannot put here. And if we put one of those ends here, oh no no no, not here, here, and not here, but here, not here, not here, not here, not. Okay, so n equals to 2 till n equals to 2, it is correct. So what we will do is just walk through. If it is 1, then we do plus 2, and after doing plus 2, if it is 0 and plus 2 and I plus 2, wait, if it is 1 and a of I plus 2 equals to 0, I plus 2 equals to 0, and a of I plus 3 equals to 0, and the one after that is also 0. Then we do n minus minus, right? And we'll do just like, and if n equals to 0, return. And if it lands on 0, like I plus plus, just like that. If it lands here, I plus 2 is 0. Yes, it is. And I plus 3 is also 0. Then n minus minus, it lands here. I plus 2 is 0. No, it is not. Then we skip. I plus 2 is 0. And I plus 3 is not 0. No, we cannot. Okay, perfect. So we don't need any of that. And for I, int I equals to 0, I less than alphabet dot size I plus plus. Hmm. Hmm. If n equals to 0, return true. If a of flower bed of I equals to 1, if it is 1, then and flower bed dot I plus 2 is 0, and flower bed I plus 3 is also 0, then n minus minus, right? Can also improve its efficiency by n minus minus and like doing I plus equals to 3. I plus equals to 3, what it's gonna do is, if it is here, all the conditions are true, I equals to I plus 3, it puts it right here after the inserted, right after the inserted one. Oh, I plus equals to 4, I should do it, because after the inserted one doesn't make sense because it cannot be inserted here. I plus equals to 4. So it puts it right here. I equals to 1, and if I equals to 1 and like this set I equals to 1, it's not, it needed to be inserted here. It cannot be inserted here. Plus equals to 4. Okay. 3, 4. Does it make sense to I plus equals to 4? Actually, it could not be, it could, uh, it could not be inserted here, right? I plus equals to 2. I plus equals to 3. it could not be inserted here because there is it either it is 1, or if it is 1, then it doesn't make sense. Either this is 1, it doesn't even make sense even more. So doesn't make sense to put it here. So plus equals to 3 plus equals to 4. This makes the correct choice because if this is 1 and this is 0, then it is correct. And if this is 1 and this, uh, if yeah, it seems correct because this is 1, we have not lost anything between these. I guess it makes sense. Okay. If n is 0 after the last iteration. Oh, we should do it right here. And okay, good. N equals to 1. We should skip the plus equals to 4 part. This is giving me nightmares. We should talk about efficiency after we have successfully uh, done the part. Oh, wait, flower minus. Oh no. This is such a simple problem, but why can't I figure this out? We checked the case for I equals to 1, but we didn't check it for I equals to 0. If I is 0 and previous one is not 1 and one after that is also not 1, then it's gonna return true. Or like n minus minus and false. Hmm. Should uh, go with 1 and like another parenthesis and we'll do or flower bed I equals to 0 and flower bed I minus 1 equals to 0 and flower bed I plus 1 equals to 0. The other two cases, yeah, I plus equals to 4, we don't need to do. Forward dot size minus 3 less than. Okay. Hmm. Okay. So if I is forward bed dot size minus 4, uh, I is 1, 2, 3, 3 places before, and it is 1, then if it is 0, 0, 0, and if it is 0, 0, 0, then it is possible for it, and if it is 0, 1, 0, then it is not possible, and if it is 0, 0, 1, then it is also not possible. So only two possibilities, only one possibility, and we have covered that, so we are fine. And if it is 0, I minus the last third element, like what we are doing is this 1, 2, 3, and if it is 1 and it is 0, 1, 0, 0, 0, then it is n minus minus only. And if this is 1, then it is not. And if this is 1, then it's not. The only possible case we have covered this. And if it is like 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, or 0, 0, 0, 0. Okay, it's like that. And the C plus 1, no. And if it is 1, and oh wait, 0, 0, 0, 1, if it lands here, we missed a case like this. This cannot do this, and after 2 it is, we also need to see. Nice. Goes to 0. Then it cannot also do that. And do this 0, 1 here. Oh, either 1 here. Oh, wait. Then it can already do this, right? Replace. And thought of that. 0, 0. Okay. We don't need to do that. Fine. Previous and after should be 0. Then we can just replace it with 1. Assuming that everything here is 0. Like 0, 0. Okay. 1. Then we move forward plus 2. right? But we should not do that. Okay. This can here something go? No. Zero, 1, 0, 0. Here it can go, but it cannot reach here. Hmm. What should we do? Hmm. I actually don't know. I actually do not know. Mm. Oh, how should we do this? Like the first approach we were, what, how we were doing it was not quite bad. Or wait, we just have to see like if there are three zeros or more than that consecutive, right? Three or more zeros consecutive. Is it seal of consecutive zeros by 2 minus 1? Greater than equals to n. Hmm. Hmm. Like this, right? If these are two zeros, this is let's say 1. And if we are here, I plus 1 equals to 0, I plus 2 equals to 0, then, oh wait, and this is not, then replace, oh wait, it doesn't matter though. Like then we will replace this or this, right? It doesn't matter. So if there are three consecutive zeros, we replace one of them, either this is either 0 or this is either 1. If this is 0, we replace this, right? And then we move plus 2 here to see if everything is correct. If like this is 1, then we replace this plus equals to 2 to see if everything is correct. Hmm. Equals to 2 plus equals to 2. The third part, we see, hmm, not quite right. Not quite right. Well, I think I'll end the stream for now because it has been too long since I've stuck on this problem. And this problem is, I feel like simple, but there are two damn edge cases. Not edge cases per se, like, what should I say? Mm, I cannot think of any of the problem. I can think about any solution. Like I've tried two approaches. First, by calculating the maximum possible flowers we can place and the flowers that are already there and subtracting them to see if the spots remaining are greater than or equal to n. Oh, what we can do is like, no, no, we cannot. I was thinking like this thing, what I'm doing, what I was doing right here, three consecutive zeros. Like we still have to see if the previous thing, if it is 0 or 1, then we can only do this. Then we have to manipulate the array itself. Oh, wait, man. Like if in I loop, in for loop, we land on 1, okay, then this has to be 0 and this has to be 0 by definition. right? By definition, if it is the default array, or if it is like this, if one is the starting position. We are taking the general case. So, assuming that we have put like placed the flowers, then only here we can place a flower here if it is not 1 and this plus 2 is not 1. Okay, right? So how many of these did we need to do? I plus 3. So on loop needs to uh, go from n minus 3 till n minus 3. Okay, if we encounter a 0, then by definition these are 1. No, these can be anything. Damn, that's why. Yeah, so we have two cases. If it is 1 and we can replace it if it is not equals to 1. If it is 1, then we cannot do anything. And if it is 0, we can replace this if it is not equals to 1. Right? Because if we cannot do anything about that. And if previous is 0, hmm, 1 to n size minus 3, and we have to see if is 1 and I plus 2 not 1, I plus 3 not 1, then n minus minus. I plus 2 equals to 1, minus minus. Else I minus 1 not 1, I plus 1 not 1, I plus I equals to 1. Simple. Else if I like in this if and then else I plus 1 equals to 1. No, I don't think this will actually work. I'm just quitting for now. I will continue tomorrow. Okay. Bye, guys.